Hello viewers, welcome to Quick Coder. My name is Tulsi. Today's topic is how can we implement queue using the linked list in Java. So let's get started. Okay, so here we are discussing about how to implement queue using the linked list. So first of all, what is a queue? Queue is a data structure which stores the set of elements. So it follows the FIFO mechanism. FIFO means first in, first out. Here, as we discussed in the previous video, the stack is having the special pointer that is called top. From the top only, the pushing and popping will be happen. So pushing and popping will be happen at the top. But here in queues, we are using two special pointers, that is rear and front, which pushing is happening at the front and popping is happening from the front. Sorry, pushing is happening from the rear and popping is happening from the front. See here the terminologies will also be changed. So pushing is called as NQ in the queues and popping is called as DQs. So for example, there is a queue and rear and front will be at the front initially. So if you want to enqueue some one element, so this element will check where is the rear. Okay, here is the rear. So one will be pushed here, sorry, enqueued here. Then my rear will coming here. Now again, I want to push 2. So R2 will check where is the rear. Okay, here is the rear. So 2 will be pushed here and rear will point into this. So now I want to DQ. DQ means nothing but DQ happens from front. So where is the front? Here. So this will be removed and front will be coming here. Okay, so very simple thing. Okay, pushing will be happening from rear, popping will be happening from front. See here, the first inserted element is only removed first. So that is called the queue. And as I already discussed, so what is the linked list? Linked list is a set of nodes, and the node is having two parts. One is the data part, and one is having the link part, and it's actually storing the address of the next node. Next node address will be stored in the this link part, and data part stores the actual data of that node. So that's it about this linked list and queues introduction. So now let me go into the coding. Okay, so let me start coding. So first of all, I'm creating a new folder, which is queue using linked list. Queue, queue using linked list. Okay, this is my folder name, and in this folder, first of all, I'm creating a file which is node.java. So because, as I said before, node is a user-defined class. So it is user-defined data type. It is having two parts. One is the data part, and another is the link part, which is storing the next node's address. So that's fine. I created the node. Now I want to create my special file, that is you using linked list. You using linked list dot java. That's fine. So here, whenever we created a queue, so first of all, what we are doing, we are initializing the rear and front. So node rear is equal to null and node front is equal to null. That's fine. So what are the simple functions I want to what I want to implement is simple enqueue, dequeue, and display method. Okay, so first of all, let me implement the enqueue method. Enqueue method is nothing but we are inserting the data into the linked list. So like enqueue, and I'm passing some x into this method. Now what I'm doing, so first of all, what is the simple thing? So as we implement a stack using the linked list, so if you see that video, this will be very easy. So first of all, what we are doing is, for example, if we want, if we have a queue and simply the rear and front, because it is an empty queue, so these are in the front position, and we are having the empty linked list. The top is not top here, actually head. But as we are implementing this queue, so let me take the rear is pointing to some null, and my friend is also pointing to some null. Okay, that's fine. So first of all, what we are doing, whenever I want to insert some data, so for example, if I want to insert 1 into the queue, then what is updating here? Rear is updating to here. That's fine. So rear is updating to here. Now, how we can implement this using the linker list is, so first of all, whenever we are inserting any data, first of all, we have to create a new node. That was the first step. Then we are inserting the data into the node. Now, my rear and front will pointing to 1. So because it is an empty linked list, so as I am now only created a new node, so first of all, the rear and front will come here. That's okay. And again, now I want to push something. So for example, I want to push 2. So the rear will be updated now. And my now in linked list, again, I'm creating a new node with putting data as 2. Now my 2 will be pointing to, so this 2's next will be, this node's next will be pointing to rear. Then my rear will be updated to here. My front will be here only. Okay. And again, what I'm doing is, for example, what I'm doing now, like for example, I inserted the 3. So 3, what I'm doing is, one second. Okay, now let us start again from the start onwards, because for example, if I want to enqueue 1 here, so then what is happening? So rear and front are at the start of the queue. So when I inserted, then rear get updated to here. Now in the linked list also the same thing happened. First of all, we are creating a node, then we are inserting 1. Then we are pointing. So as this is the first node in the linked list, so rear and front will come here only. Okay, so that's fine. And again, I want to enqueue 2. What here happening? Okay, 2 is inserting, then rear is updating. Here also, so first of all, I want to create a node with 2. With 2, I'm creating a node. Then, okay, the deleting and inserting. So inserting will be happening at rear. So what I want to do is, okay, this rear dot next will be this node. Okay, so this rear dot next will be this node. Then rear will be updating to here. Front will be here only. Okay, is this fine? And again see, I want to insert 3 here. So 3 will be inserted at the rear position, then rear will be updated to here. Then again in the linked list also, first of all, we are creating a node and inserting 3. I mean keeping data as 3. Now what I'm doing is this, where my rear, here is my rear. So rear dot next will be this new node, then rear will be updating to this node. Now, okay, so first of all, we can implement this queue, then we can come to the dequeue. Okay, let me implement this queue first of all. Okay, so first of all, what I'm doing is, first of all, whenever I'm inserting something, I want to create a new node. So node is equal to new node. Then node dot data is equal to this x. Now, first of all, I want to check if my rear is equal to null. So means my linked list is null at first. So my rear is equal to front is equal to node. This rear and front will be pointing to node, because these two are first of all pointing to, see here, this rear and front are pointing to null at first. So whenever this rear is null, okay, so this is the first node. So then rear and front will coming to here. Okay, so that's the thing that I wrote here. Now else. So what is the else position? Else simply we are pointing our rear to rear dot next to this node. See here, rear dot next to this node. Then I'm pointing my rear as this node. Simple thing. What I'm doing first of all, see when I inserted, see when I want to insert 4 now, so new node is created. Okay, it goes to the else position because rear is not equal to none. So my okay 4. My here is my rear. Rear dot next will point to this node. That's okay. Now my rear will be node. This will be my node. Okay, so that's the very simple functions in this. Now let us do what will happen in dequeue. Okay. Okay, now I just simplified the function, like my linked list diagram, so that you can understand very easily. So first of all, what I want to do is I want to dequeue something. So dequeue will be happening at front. So what happens if my front is null, because there is no node in the linked list, my front will pointing to null. So if my friend is null, then I can simply tell, okay, my queue is not empty. Sorry, my queue is empty. So if my friend is not equal to null, so what I have to do? Simple. Simple, what I want to do is, because I want to discard this node, okay, what I'm doing now is very simple operation, very one line operation. What I'm doing is my friend will be coming to this here. Simple. I'm not just removing this node, nothing is doing. So I'm just taking my friend to this. That's it. Very easy. A very easy line. So what I'm doing, then here there is something. For example, okay, and again I call the dequeue function. Now my friend going to this here, and again I am calling the dequeue function. So what is happening? My friend is now going into the next one, that is null. So if my friend is null, so what I want to do, my ray should also be pointing to null. Okay, again I will explain. I will explain. Don't worry. For example, this is my linked list stretch. This is something like null, and this is my data. Oh, and this is my friend, and this is my ray. Okay, is it fine? Now what I'm doing is, first of all, I call dequeue function first time. Then what I'm doing, just I'm just taking this friend to here. Okay, this will be not my friend now. Remove this friend. Now again I'm calling the dequeue function. Okay, my friend will come here. And again I'm calling the dequeue function. Okay, my friend will come here. So what I want to do, my friend will be now null. Then I have to set my rear as also null, because still it is pointing to 3, means the linked list is not empty. But in this case, when I call dequeue function 3 times, here I am removing this. My friend came to null. Again, I have to put my rear as also null if my friend becomes null. Okay. So the simple operation is, I will write it down. If my if my friend is equal to null. So first of all, we have to check if my friend is equal to null, then my queue is empty. My queue is empty. That's fine. Okay, my queue is empty. Now what happens else? What happens in else? Just I'm simply taking my friend to its next. That's fine. And if my friend is equal to null, so what I want to do, I want to make my array as also null. That's very simple operation. And one more operation that I want to do is like display method also. This display method is also very easy. Like if you see my previous video, means how to implement stack using the linked list. So there also I explained. So display method. Display method is like, so first of all, you are taking the temporary node and pointing it to front. Now my while my temporary node is not equal to null, then I'm just printing that data, like system dot out dot print f, just simply doing this percentage to of temp dot data. Okay, now I'm making my temp is equal to temp dot next. Then at last line I'm making it as like temp dot no. That's fine. Okay, so I will explain this, don't worry. So with the same example, let me erase this all the things. So here what is actually happening is, first of all, my friend will be here. Okay, my friend will be here and my rear will be here. So first of all, I want to traverse through this linked list. I will create a temp and pointing to this friend, because I can also traverse this friend, but this friend should be here only, no? It should not be moved. So I am taking the temporary node and pointing to this friend. Now I'm making a while loop while my friend, while my temp, because my temp is here now. So here my temp is not equal to null. So I'm printing this data like 1. Now again my temp is going to the temp dot next. Okay, here there will be temp dot next. Here temp is not equal to null, so I will print the temp dot data. Now I again moving to the next node. Here also my temp is not equal to null. So I will print the temp dot data. Now I will move to this temp. Here my temp is equal to null. So I should not go into this while loop. I come out and I will print null. That's it. A very easy function. Now let me implement the main method. So how can I implement the main method? So first of all, let me save this. I will implement a main method. Like let me name it as a QAdapter.java. So here I am implementing main method. So in this main method, first of all, I want to create a object for this Q using linked list. So linked list Q is equal to new Q using linked list. Okay, that's fine. Now I want to make some NQ operations like NQ. Why it is not showing? Okay, public void NQ. Okay, I want to pass just one. That's fine. And again, I want to make Q dot NQ. Now I want to push the data to. Now I want to call Q dot NQ. I want to push the data. Now I want to call, like I want to display, call the display method to see how my linked list is looking like. Okay, that's also fine now. Now I want to DQ. I want to DQ the method, and again I want to DQ. And again, so I want to call now for display method. Okay, that's again fine. Now I want to call the DQ method. That's also fine. And again I want to like call the display method. Now again I want to call the DQ method. Okay, now let us see. Let us save this and let us run this. Okay, I want to change the path as cd u using linked list. Okay, using linked list. Okay, that's fine. If I want to say java space q adapter java. Okay, let us wait. Okay, it is showing. Oh, sorry. So that is the reason it does not show me the correct things while I'm writing in Q. Like, see here. Okay. Now I can save this and maybe I want to run. It's Q adapter. Okay, it's fine. Now Java space Q adapter. Let's see what will be the output now. Yeah, that's cool. So first of all, what we are doing, we are inserting 1, 2, 3, then we are displaying. So 1, 2, 3, that's fine. Now I am calling DQ 2 times. So the first inserted will be removed, means 1 and 2 will be removed. Okay, 3 and null will be there. And again I am calling display method. Okay, now again calling the DQ method. DQ method 3 will also be removed. Then again display method, only null is there. And again I am calling DQ method, but nothing is there. So it's calling like Q is empty. So this is the simple implementation of Q using the linked list. Okay, thank you friends. Thank you for watching this video. The coming up video is finding the middle of the linked list in Java. So subscribe to my channel, Coder, to get notifications about the new videos. Thank you. Thank you for watching.